Hello everyone, my name is Sayala Sosnuroshadi from Select UPC 2017, and in this occasion I would like to present to you a thesis about study and design of hybrid off-grid PV generator power plant, PV generator power system for administration load in three regions in Indonesia. This is the outline of presentation. We will start from overview and we will see the location and load profile for this proposed project, and we will see the reason behind the system and component determination, and finally we will see the result and analysis and of course conclusion of this project. And nowadays Indonesia has low electrification ratio, and moreover there is 12,000 remote villages there that still haven't get an access of electricity. Meanwhile, renewable energy distributed generation could become a good solution because renewable energy distributed generation, which also can be combined or hybrid with the another conventional generation, could provide electricity directly without depending too much to the national grid. And the other one, the government of Indonesia nowadays want to increase the renewable energy fraction in energy mix at 2025 from about 6% to 23%. It means that it is compulsory for Indonesia to increase the development of renewable energy infrastructures across the land. And moreover, nowadays there is a declining PV component price worldwide. This is the tools that were used for this simulation for this project. The first one is Homer Pro, the second one is PVSys. The simulation result from Homer Pro, it is an optimized result in economic and also in technical design, but it's very general in technical point of view. So it should be assessed again, verified using the PVSys software, and after the technical details is verified using PVSys software, the simulation result should be simulated again to the Homer Pro software to get a more objective economic result. And this is the area for this project. The first one is Aceh Singkil in the west of Indonesia, Alor in the middle, and Raja Ampat in the east. And this is the solar irradiance for those three regions. And this is the load data, the load profile, because this thesis is focusing on the load of the administration office, such as municipality of villages or something like that. So this is the typical data of the load for administration office, which has peak load in 1 kilowatt and also daily energy consumption in 11 kilowatt hour per day. And this is the component determination. First of all, for PV module, the one that we considered is peak power and also market price. And for battery, the most important point is energy demands and the autonomy time. It means that the time when battery could still provide electricity without any energy sources available. And the inverter should be suitable and appropriate with the capacity of the PV modules, and the generator as the backup should cover the peak load of the energy demands. And this is the key indicator. Basically, in this thesis, the comparison is between the PV hybrid generator sim with the generator only power plant, which is very common in Indonesia to electrify the rural areas. So this is the key indicator is levelized cost of electricity, which is the ratio between total annualized cost with the total annual energy consumed by the load. So this is the result. We could see here that the PV hybrid generator solution could reveals more lower LCOA. It is because we can save more money for the fuel and also for the accommodation for the fuel to get into the villages. And if we see into the another level of load, we could see that it is inversely proportional to the gap of LCOA or levelized cost of electricity. More higher the load, more smaller the gap of LCOA between generator only, which is the conventional way to electrify villages, with the renewable hybrid using PV as primary sources, with the generator. So the conclusion is this way of development for hybrid PV generator power plant system technically and economically feasible using those two software. And also we could see that LCOA of hybrid PV generator power plant for this solution could save 36 into 42% of generator only LCOA. And hybrid sim also has advantages of lower level of carbon emission, of course. And load level is inversely proportional to the gap of LCOA between hybrid sim and conventional generator sim. That's all for me. Thank you for your attention and have a nice day.